Hello and welcome to this video on what is climate acceleration and what are its already visible and future effects. Climate acceleration is an ongoing phenomenon that has already had a strong impact on our planet and is expected to continue in the future. Due to harmful human activities such as burning fossil fuels or cutting down forests, the rate at which Earth's natural climate is changing has risen. Let's explore some effects that are already visible, as well as what the predictions are for the coming century. The planet's average surface temperature has risen about 1.18 degrees Celsius since the late 19th century, a change driven largely by increased carbon dioxide emissions into the atmosphere and other human activities. The ocean has absorbed much of this increased heat, with the top 100 meters of ocean showing warming of more than 0.33 degrees Celsius since 1969. Our planet stores 90% of the extra energy in the ocean, so all the effects that are felt on land are only a small fraction of the true impact that climate change has on Earth. The Greenland and Antarctic ice sheets have decreased in mass. Data from NASA's Gravity Recovery and Climate Experiment show Greenland lost an average of 279 billion tons of ice per year between 1993 and 2019, while Antarctica lost about 148 billion tons of ice each year. Glaciers are retreating almost everywhere around the world. This is one of the most direct and visible effects of global warming. For instance, the famed snows of Kilimanjaro have melted more than 80% since 1912. Glaciers in the Himalaya in India are retreating so fast that researchers believe that most central and eastern Himalayan glaciers could virtually disappear by 2035. Global sea level has been rising over the past century, and the rate has increased in recent decades, particularly due to the melting of ice sheets, with great amounts of water being released each year. In 2014, global sea level was 6.6 centimeters above the 1993 average. Sea level continues to rise at a rate of about 3.3 millimeters per year. This puts coastal communities at risk and is a serious threat for island nations such as Tuvalu in the Pacific Ocean or the Maldives. The ocean also absorbs about a quarter of the CO2 we release into the atmosphere every year. So as atmospheric CO2 levels increase, so do the levels in the ocean. This decreases the pH of the ocean, making it more acidic, which leads to altered conditions for many marine plants and animals. Most vulnerable are coral reefs, which have been suffering more and more mass bleaching events due to the high acidity of the ocean. The rate of climatic change in the next century is expected to be significantly higher than it has been in the past. At our current rate of emissions, the Intergovernmental Panel on Climate Change, or the IPCC, estimates that CO2 levels in the atmosphere will double or triple during the next century, and the climate system will respond. Let's dive into some of the predicted impacts that this might have. Climate models predict that Earth's global average temperature will rise in the future. If we continue to emit as many or more greenhouse gases, this will cause more warming during the 21st century than we have ever seen before. Various computer models predict that Earth's average temperature will rise between 1.8 and 4 degrees Celsius. The map on the left corresponds to a future where greenhouse gas emissions are substantially reduced immediately and net CO2 emissions become negative near the end of the 21st century. The map on the right, however, corresponds to a future in which greenhouse gas emissions continue to grow. Warmer average global temperatures will cause a higher rate of evaporation, causing the water cycle to speed up. More water vapor in the atmosphere will lead to more precipitation. According to models, global average precipitation will most likely increase by 3 to 5%. Yet, changes in precipitation will not be evenly distributed. Some locations will get more snow, others will see less rain. Warmer air temperatures have already affected the length of the growing season over large parts of Europe. Flowering and harvest dates for cereal crops are now happening several days earlier in the season. These changes are expected to continue in many regions. In general, in Northern Europe, agricultural productivity might increase due to a longer growing season and an extension of the frost-free period. In Southern Europe, however, extreme heat events and reductions in precipitation and water availability are expected to hamper crop productivity. Some climate scientists believe that hurricanes, typhoons, and other tropical cyclones will change as a result of global warming. Warm ocean surface waters provide the energy that drives these immense storms, so warmer oceans in the future are expected to cause intensification of such storms. Although there may not be more tropical cyclones worldwide in the future, some scientists believe there will be a higher proportion of the most powerful and destructive storms. In the next several decades, storm surges and high tides could combine with sea level rise and land subsidence to further increase flooding in many regions. Computer models reveal that some coastal cities may be submerged by the end of the century, but sea levels will continue to rise past 2100 because the oceans take a very long time to respond to warmer conditions at the Earth's surface.